Hello students, Callie Daniels here. In this video we will learn about the addition property of equality as we investigate linear equations, and inequalities will come soon. First of all, a linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers, and a can't be 0, because if it were, we would have 0 times x, which is 0, and there would be no variable. Okay? We need that variable in here to the first power for this to be considered a linear equation in one variable. Some examples of linear equations in one variable: 4x plus 9 equal 0 is 1, or 1/2 x minus 3 is equal to 1. There's another example of a linear equation in one variable. Or maybe even just 5 times x equal -10. Now the main thing that we need to see for this to be a linear equation in one variable is that it's got to have a variable. In this case, we're seeing the variable x, and that variable needs to be to the first power. In other words, it has an exponent of 1, and we don't have to write those exponents in there. When we see the variable x by itself, we know that there's 1x there. Okay, writing the 1 is redundant. Nonetheless, that's what makes these linear in nature. Okay, well, a solution of an equation is a number that makes the equation true. For example, in this last equation, 5 times some value, some unknown, is equal to -10. Well, I think we could determine that 5 times -2 is -10, and therefore the variable x must take on the value -2. Therefore, we would say that the solution to this equation is x equal -2. -2 makes the equation true because 5 times -2 is -10, and that checks out. Well, to use the addition property of equality to solve an equation, okay, that basically says that we can add the same thing to each side of an equation and it will remain the same or have the same answer. If a, b, and c are real numbers, then the equations a equal b, so there's our equation, and a plus c equal b plus c are equivalent. So here the same number c has been added to each side of the equation, and that does not change the solution. Well, let's use this addition property of equality to solve each of the following equations. Part A, x minus 12 equal -3. Well, we would like the last step of this equation to look like what we found above. X is equal to some number. So our goal is to isolate the variable x. We can do that if we eliminate the term minus 12. So we're going to think in terms of the additive inverse. Okay, what do we add to -12, okay, to get it to cancel out or become 0? Well, positive 12. So to the left-hand side, x minus 12, we will add 12. So correspondingly to the right-hand side, we must also add 12. So see, we've added 12 to each side of that equation. So what does that give us? -12 and positive 12 are 0. So on the left-hand side, we've got x plus 0, or just x. On the right, -3 plus 12 is 9. And the solution to this equation is 9. Now, we can easily check this answer by substituting it into the original equation. Okay, if we replace x with 9, is 9 minus 12 really equal to -3? It sure is. -3 is -3, and that checks out because it's a true statement. Well, let's look at another one in part B. 7/2 x plus 1 is equal to 9/2 x. Now this has fractions, but don't let that stop you from just moving forward and isolating the variable x. Now we see the x term on both sides, so let's do something that's going to move the x terms to the same side. Okay, so how about we subtract 7/2 x from each side, and that's essentially going to transfer it over to the right. Here we go. 7/2 x minus 7/2 x plus 1 is equal to 9/2 x minus 7/2 x. So within that addition property of equality falls the subtraction property of equality. We can subtract the same thing from each side of an equation. So we've subtracted 7/2 x from each side, haven't we? And this equation is still balanced. Now, 7/2 x minus itself is 0, so that leaves the number 1 on the left-hand side. On the right, 9/2 x minus 7/2 x. These have the same denominator, woo, woo. So just subtract the numerator, okay? 9 minus 7, that's 2/2 x. Subtract the numerators, keep the same denominator. All right, so 1 is equal to, well, 2/2 is the number 1, isn't it? Okay, and 1x is just x. X is equal to 1. Now, for some reason, I like to write the x on the left-hand side. That's just me. You don't really have to do that. But our solution here is x equal 1. And you can check that by substituting back in the original equation. Let's look at one more example here, parts A and B, where we simplify and then use the addition property of equality to solve each equation. In part A, we're going to simplify by combining our like terms, all right? On the left, 9r plus 4r is 13r, and 6 minus 2 is 4. Now on the right-hand side, combining like terms, 9r plus 3r is 12r. And we also have the plus 4 in there as well. All right, now we see our variable term on both sides, and we've got a number term on both sides. Now I would like to move the variables to the left and the numbers to the right. And so I'm going to subtract 12r from each side. I'm going to start there. All right, now I'm just going to pencil this minus 12r below on each side of the equation. Just kind of thinking my way through this, okay? Because on the right-hand side, that's going to eliminate 12r. Now on the left-hand side, 13r minus 12r is 1r, or just r. So what do we have? We've got r plus 4 is equal to 4. So we've moved the r's over to the left. Now we're going to move the numbers over to the right. Okay. To isolate our variable, we will subtract 4 from each side. And I'm just going to pencil that down below, okay? So I'm going to subtract 4 from the left and subtract 4 from the right. Okay, so that 4 cancels off the left, leaving r. And notice it cancels on the right as well, doesn't it? 4 minus 4 is 0. Now, this doesn't mean there's not a solution to this equation. There is a solution, and it happens to be the number 0. Okay, and why don't we check this one also? Remember to always check in your original equation. So up here we'll replace r with 0 everywhere we see it. Is 9 times 0 plus 4 times 0 plus 6 minus 2 equal to 9 times 0 plus 4 plus 3 times 0. Well, this is going to work out nicely because 0 times anything is 0. So we've got 4 terms that are zeroing out. On the left, 6 minus 2 is 4. On the right, we've got 4, and that's a true statement, and we're feeling really confident right now about our work. Last problem for this section, okay? Part B. We're going to simplify, then solve. Now, let's use our distributive property. Here we go. 4 times x plus 4 times 1. That's 4. Now, be careful here. With our second set of parentheses, we're going to distribute that minus sign, or you might think of it as -1 times both of those terms, okay? -1 times 3x is -3x, and -1 times 5 is -5, okay? So notice the 3x plus 5 became -3x minus 5. Now let's combine our like terms. 4x minus 3x is 1x, or x. 4 minus 5 is -1. And last step, to isolate x, okay, we're going to use our additive inverse. So be thinking to yourself, what's the opposite of -1? Well, +1. -1 plus 1 is 0, isn't it? We want to zero out that -1 term. So again, I'm just going to pencil here down below, +1, and make sure we do it to both sides. Let's keep this thing balanced. And that gives x is equal to 2. And I will let you check that one. All right, students, there we go. Here we have solved linear equations using the addition property of equality. Good luck on these.